Hi, 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 hi. Hope all of you are doing good. Even I'm doing good. Can be better. So I'm back with the part two of some basic concepts of chemistry, which is the first chapter of class 11. As you all know, we have already completed the part one of this chapter. In the part one, we have actually discussed about the matter, the different states of matter, and the properties of matter. Also, we have classified matter into pure substances and mixtures, and we have further divided pure substances and mixtures to two categories each, right? Then we have come across five laws of chemical combination: law of multiple proportion, law of conservation of mass, law of definite proportion, Gay-Lussac's law of gaseous volume, and finally Avogadro's law, right? We have already discussed all the laws. So what you have to know about these five laws is that the name of the scientist who proposed the law and the title of the law or the name of the law, and you need to know to state the law and to illustrate the law with an example. Fine. All these four things must be known to each and every plus one student. Okay. Now we are going to answer a few questions. Fine. Fine, fine, fine. All set? Okay. Classify the following matter as homogeneous mixture, heterogeneous mixture, element, and compound. So let me tell you what is an homogeneous mixture, heterogeneous mixture, element, and compound. I know I've already explained it to you very well, but still, we need a recap, right? Yes, you guys need a recap. I know that. So, element and compound, they fall under the category of pure substances. Yes, pure substances, and we have mixtures also. Which are the they are the two classifications of matter. Matter can be classified into pure substances, mixtures. In pure substances, we have element and compound. Both the element and compound fall into the periodic table. Okay, element means two types of same type of atoms combined will form an element. Different type of atoms when combined they form compound. For example, CO2 can be can be a compound, but H2 can be an element, because same type of element when same type of atom when combined it forms element, and different type of atoms when combined it forms an and it forms a compound. Fine. Coming to mixtures, we have pure homogeneous mixture and heterogeneous mixture. In homogeneous mixture, it will be uniformly distributed. The properties will be uniform everywhere. But in the case of heterogeneous mixture, the solute will not be dissolved properly in solvent. So with this knowledge, okay, with the knowledge you have acquired from my sessions, tell me the first one, gold. Is it a homogeneous mixture, heterogeneous mixture, element, or compound? I've already told you one good tip to understand whether a substance is an element or compound. Whenever something comes under the periodic table, it will obviously be an element or a compound. Fine. Gold. Gold. Do you find gold in periodic table? Yes, exactly. Yes. So gold is obviously an element. Element. What about gold ornament? If the question is gold ornament, what will you write? What will you write? Gold ornament. Is it an element, pure substance, or homogeneous substance, or heterogeneous substance, or compound? Gold is an element for sure. You can see it in the periodic table. What about gold ornament? Think, think, think. Hmm. Yes, gold ornament is a mixture. Obviously, it's a mixture, and it's a homogeneous mixture. Yes, homogeneous mixture. Homogeneous mixture. Why is it a mixture? Because in gold ornament, not only gold, but we can also see copper, yeah, so as to provide stiffness to the ornament. So you have already heard 916, right? Which means 91.6% of gold, and remaining will be copper or Cu. So it is copper is uniformly distributed in gold ornament, hence it is a homogeneous mixture. Fine. It's a mixture of two substances. Next is air. Air is a heterogeneous mixture, homogeneous mixture, or what? Element or compound? Do you find air in a periodic table? No. So just leave that section. Leave the section of pure substances and come into the section of mixtures. Air is a homogeneous mixture or heterogeneous mixture? Yes, air is a homogeneous mixture. Homogeneous mixture because air has many components of gases in it and it's uniformly distributed, or a particular composition of each gas is uniformly distributed all over the surroundings. Muddy water, very simple, right? It is heterogeneous mixture. Heterogeneous mixture. What about water? H2O. H2O. Do you see hydrogen in periodic table? Yes. Do you see oxygen in periodic table? Yes. So what is water? Water is a compound formed by combining two different atoms. Next question is, NO and NO2 are two oxides of nitrogen. Which law of chemical combination is illustrated here, and state the law? NO and NO2 are two oxides of nitrogen. Okay, when nitrogen combines with oxygen, we get NO2 and NO. So which law is illustrated here? And you need to state the law also. Which is the law? We have many laws here. We have already studied Avogadro's law. Is it Avogadro's law? Or is it Gay-Lussac's law? Or is it law of multiple proportion? Law of definite proportion? Or law of conservation of mass? Okay, this one? No. This one? Sure? Sure? Yes. It is law of multiple proportion. NO and NO2 are two oxides of nitrogen, means if two elements combine to form more than two compounds. If nitrogen and oxygen combine to form more than two compounds, that is NO and NO2, the different masses of one of the elements combined with fixed mass of other element bears a simple whole number ratio. Simple. So in the question, which law is illustrated means you just have to mention the name of the law. Here state the law is there, so you need to explain the law. Next question is, how many significant figures are present in the following numbers? So I haven't taken significant figures, the topic of significant figures to you, because I was waiting for this question to come so that I can explain this topic to you with the help of few questions. So significant figures means it is from 0 to 9. 0 to 9. In between this 1, 2, 3, 4, let me more precisely say, just let me tell 1 to 9. The numbers in between 1 to 9 are what? Significant figures. Okay, the numbers between 1 to 9 are significant figures. Then what about 0? 0 is a significant figure and 0 is not a significant figure. 0 is a significant figure and 0 is not a significant figure. And you might be thinking, why am I saying like this? She's also saying that it is a significant figure. She's also saying like it's not a significant figure. Why? The thing is that the position of 0 determines or decides whether it is a significant figure or not. So the position of 0 matters. You already know that the numbers between 1 and 9 are significant figures. So let me see. If a number is starting with 0, 0, 0 and 2, 1, 3 somewhat, the zeros are in the beginning, right? This is not a significant figure. Zeros are not a significant figure in this case. Fine. If the number starts with few zeros, then those zeros are not significant figures. Now, the next case is that if a number has few zeros in between 2, 0, 0, 2, the zeros in between two significant figures is a significant figure. Fine. The zeros in between two significant figures is always a significant figure. Clear? Clear? Then comes 2, 2, 0, 0, 0. the zeros after few significant figures or to the end of a number can be a significant figure and cannot or may not be a significant figure. If it has no decimal points, if the zeros have no decimal points in between, then it is not counted as a significant figure. If the zeros have a significant figure in between, see this, I'm denoting a decimal place or decimal point by this red color, then all these zeros are countable as significant figures. If it is just plainly 0, 0, 0, 2, 2, 2, then these zeros are not significant figures. If it has a decimal point in between, then it is obviously a significant figure. Hope the rules are very clear. Let me explain one more time. All the numbers between 1 and 9 are significant figures. Then coming to zeros, the zeros in the beginning of a number is not counted as the zero in the beginning of a number is not counted as a significant figure. The zero in between two significant figures or two or more significant figures in between, they are counted as significant figures. The zero at the end of a number, okay, that zero is not counted as a significant figure if it does not have a decimal point. Okay, it is counted as a significant figure. The zero at the end of a number is counted as a significant figure if it has decimal point. Clear? Now let's answer to these questions. 0.00025. 0.0025. How many significant figures are there? Tell me, how many significant figures are there? There are zeros in the beginning, and no matter whether decimal point is there or not, the zeros in the beginning is not a significant figure. It's not counted as a significant figure. So 2 and 5 are two significant figures. So this number has two significant figures. This number has two significant figures. In the case of 208, you already know that 2 and 8 are significant figures. What about the zero in between? I've already told you that the zeros in between significant figures are always counted as significant figures. Hence, this has three significant figures. Clear? What about the third question, 5005? Same type. So hence, four significant figures, 5005. See to the next question, 126, 000. 1,26,000. What about that? How many significant figures you are able to see there? Is it 3 or 6 or any other number? The zeros to the end of the number is counted as a significant figure if and only if a decimal point is there. Are you able to see a decimal point there? No. You're not able to see a decimal point there, so those zeros are not counted as significant figures. Hence, we have three significant figures here. That is 1, 2, 6. 500.0. The fifth question, 500.0. Yes, four significant figures there. 500.0. Okay. You have four significant figures there. 2.0034. Yeah, simple. You have 5 decimal points there. Instead of this, instead of 2.0034, we have 20034. What will be your answer to the same question? How many significant figures in 20034? You know, you don't have decimal points in between. So what will be your answer? How many significant figures in between? Same, 5 itself. 5. All right. Okay, now we are moving on to a topic called Dalton's atomic theory. Dalton's atomic theory. So, you might have learned about many atomic theories in your previous classes, or you might not. But you need to know the fact that there are many atomic theories that led to the further realizations about atom. Okay, you know what an atom is because you have studied about atom in your 10th standard, right? an atom. So the first acceptable theory about an atom or the structure of atom was provided by Dalton. Clear? The very first acceptable theory about an atom was provided by Dalton, scientist Dalton. But you also need to know that Dalton's atomic theory, or the theory we are going to study now, has got a lot of limitations and drawbacks. Okay, the theory we're going to learn now, that is a Dalton's atomic theory, the primitive theory about the atom, it has got a lot of limitations and drawbacks. But the positive thing, what it has done to the science, the area of science or the field of science, is that it has led many scientists to think about the possibilities of an atom. Okay, it has led many scientists to think about atom more further, more deeper. All right, so let us learn. You might think, okay, anyways, it's a failure. The theory was a failure. Then why do we have to learn about it? We have to learn about this theory because it was a primitive theory or well accepted theory of atom, which was given by Dalton in I think many centuries back. Okay, many centuries back, or the primitive theory by Dalton about atom. So let us look on to the postulates, the 5 postulates of Dalton's atomic theory. The first postulate is that matter consists of indivisible atoms. You know what a matter is? Anything that has mass and occupies a space is called matter. Right? Anything that has mass and when it occupies a space, it's called a matter. So according to Dalton, he says that matter consists of any matters in our surroundings. It consists of indivisible atoms. But according to our current theory or current knowledge, or according to our current level of knowledge, we know that the very first postulate is itself a wrong statement. Because when atom is further divided, we get electrons, protons, neutrons, etc. So what we can acquire from this, the first postulate, Dalton's atomic theory as a whole, can be a failure, right? Because the further studies have proved that many of these postulates are wrong. But still, as it's a primitive theory, we need to know about it. We shouldn't forget the route through which we have passed, right? So we have traveled. So due to that, we need to know this. Matter consists of indivisible atoms because atoms, when divided, we can see electrons, protons, neutrons, etc. But in those stages, he said that matter, when divided, it has atom, okay, which cannot be further divided. Fine. The second postulate he made is that all atoms of a given element have identical properties, including identical mass. Okay, when I take an element, let it be chlorine, he's saying that any atom of the chlorine element will be same, okay, in its mass, in its properties and everything. But as per our current knowledge, is it true or is it a wrong statement? Tell me. You have already learned about isotopes, right? Isotope. What is isotope? Atoms of same element having different properties, right? Different properties, different mass numbers. So even in the case of chlorine, we have different isotopes of chlorine itself that have different properties. Isotope means atoms of same element having different properties. So as per our current knowledge, we can say that the second postulate is also wrong. He has said that an element has all its atoms identical in properties and mass. But there are elements with atoms different in properties, and they are called isotopes. Coming to our third property. Okay, third property is this. Okay, fine. Let me mark it as third. This is third, and this is fourth, and this is fifth. Atoms of different elements differ in mass. Different elements have different atoms and they differ in mass. But we know that there are atoms of different elements which have same properties and they are called isobars. You've already learned about isobars, isotopes, isotons, etc., right? So, according to Dalton, he's saying that different elements have different atoms and they are different in mass and other properties. But according to our current level of knowledge, we are sure that there are atoms of different elements which have same properties, and they are called isobars. Okay, when I was learning about Dalton's atomic theory, you need to know the later version of it. Okay, later version of it. You shouldn't stick on to the Dalton's atomic theory because it has progressed a lot over years. Fine. The fourth postulate is that compounds are formed when atoms of different elements combined in a fixed ratio. You already know about that, right? Law of definite proportion. In law of definite proportion, we have learned about it. When two elements combined in a fixed ratio, they form a product or they form a compound. So as to form CO2, we need to combine carbon and oxygen in that particular ratio. So as to form hydrogen peroxide, we need to form we need to combine hydrogen and oxygen in a particular ratio. Otherwise, it will form any other product, any other compound. So the same is said here, compounds are formed by combining elements in a fixed ratio, And the final postulate, the fifth postulate, chemical reactions involve reorganization of atoms. Okay, that is just nothing like atoms when reorganized they form products. These are neither created nor destroyed in a chemical reaction. You need to know about that very clearly. According to Dalton, he's saying that atoms can neither be created nor be destroyed. You know mass conservation law, right? Law of conservation of mass. In that conservation law, it is saying that mass is neither being created nor being destroyed. And we even proved it, right? But in the case of Dalton's atomic theory, the fifth postulate says that atoms can neither be created nor be destroyed. But we are so sure that atoms can be created, and there are a lot of man-made atoms nowadays. So, the fifth postulate of Dalton is that atoms can neither be created nor be destroyed. When atoms get reorganized, it forms compounds through chemical reactions. So, Dalton's atomic theory is very important in the exam point of view because they directly ask you to write the 5 postulates of Dalton. So, which are the 5 postulates of Dalton? First of all, matter consists of indivisible atoms. And he says that these atoms are not being created or destroyed. When atoms reorganize, they form products by chemical reactions. Atoms of different element differ in properties. Atoms of same element are same in properties or mass. Okay, fine. Now we are moving on to a question. Calculate the molecular mass of glucose. The molecular formula is given there, C6H12O6. Calculate the molecular mass of glucose molecule. So you need to know what a molecule is. What is a molecule? When two atoms combine, we get a molecule. When two atoms combine, we get a molecule. So consider H2. H2 is a molecule because H and H, two hydrogen atoms are combined and there forms a molecule. H2. CO2. CO2 is also a molecule because carbon and oxygen are combining here and they form a molecule. But there is a difference between both, right? Here, the same type of atom is formed. In the case of H2, same type of atom is called formed, and hence it is called element. In the second case, that is of CO2, different type of atoms is combined. Different types of atoms are combined, and hence they are called compound. So when two atoms combine, they are generally called a molecule. When the atoms are of same type, they are called an element, and when the atoms are of different type, they are called compounds. So let's see to this question now. This is a numerical problem from NCERT, and which is very easy to solve. Calculate the molecular mass of glucose. We have already been provided with the molecular formula C6H12O6. So what you have to do when you're finding molecular formula? You already know the molar mass of a species, right? For carbon, it is 12, right? You need to multiply this mass with the number of atoms provided. Carbon has 6 atoms in the molecular formula, so 12 into 6 plus hydrogen. What is the mass of hydrogen? 1 into 12. because in the molecular formula there are 12 hydrogen atoms plus oxygen. Oxygen is 16. Yes, 16 into 6. In the molecular formula there are 6 hydrogen atoms. So in total you will get 180.162U. 0.162U is not 1.162 isn't actually essential. 180 is essential. 180. Answer will be 180U. Or you can write it as 180 AMU. This is a unit to express molecular mass. Okay. AMU, atomic mass unit, or U, unified mass. So I'll tell you about the story of U and AMU in the part 3 of this chapter. For the time being, I'll wind up the session by just we'll just recap what all we took today. We have solved few problems. The first problem was from the topic of homogeneous mixture, heterogeneous mixture, then elements and compounds. In the second question, the question was from law of multiple proportion. We stated the law too. In the third section or the third question, we learned a new topic, significant figures. In significant figures, you need to remember one thing: the zeros in the beginning is not a significant figure, zeros in between is counted as a significant figure, and the zeros at the end is counted as a significant figure if and only if there is a decimal point. Yes, right. Then we came to know the postulates of Dalton's atomic theory, 5 postulates. Okay. Then finally, we solved a numerical problem from NCERT. Okay. Hope you enjoyed today's class, and we'll surely meet in the other class. Okay. We should meet. Fine. Okay. Be prepared for the next session. Bye bye.